Exhaust gas recirculation, EGR for short, is an important pollutant reduction method in petrol and diesel engines. Here we can see its basic structure. Exhaust gas is taken directly after the cylinders. Then, the EGR valve regulates the subsequent mixing of the exhaust gas with the intake air. This means that less oxygen reaches the cylinder. Less oxygen means a lower combustion temperature. This way, nitrogen oxide quantities can be reduced by up to 70%. As the higher the temperature, the more harmful nitrogen oxides are produced. In petrol engines, this can also reduce carbon dioxide emissions and fuel consumption. A key component of exhaust gas recirculation is the EGR valve. It meters the quantity of exhaust gas that is returned. EGR valves come in various designs and models, pneumatic or electrical, for petrol or diesel applications, or with connections for cooling. Regulating throttles are used in the intake air system in diesel vehicles. They generate the pressure difference required between the exhaust gas side and intake side to achieve the necessary high exhaust gas recirculation rates. Air mass sensors are required in diesel engines to regulate the exhaust gas recirculation, for example. With their help, the mass of the recirculated exhaust gas is calculated indirectly using the reduction of intake air. Since simple exhaust gas recirculation has no longer been sufficient to fulfill emission standards for some time, EGR coolers are used. Cooled exhaust gas reduces the peak combustion temperature even further. This again significantly reduces the amount of nitrogen oxides. Just like all components in the EGR system, EGR coolers are exposed to the extreme conditions of the aggressive exhaust gas condensate. They must therefore be manufactured from highly corrosion and temperature-resistant materials. Many of today's EGR coolers feature an electrical or pneumatic bypass flap. They allow the exhaust gases to be directed past the EGR cooler in the warm-up phase to quickly bring the engine and catalytic converter to operating temperature. This also reduces noise generation, the so-called diesel knock, and the raw emission of hydrocarbons in the warm-up phase. Bypassing is also possible if high exhaust gas temperatures are required, for example in the recovery of the diesel particulate filter. The previous high-pressure exhaust gas recirculation system is no longer sufficient for meeting the limit values as of Euro 6 and Tier 2. An additional low-pressure EGR system is required. With this system, the exhaust gas is taken after the particulate filter on the low-pressure side and added again before the turbocharger compressor. An exhaust gas flap provides the exhaust gas back pressure required for this. Pierburg is a significant contributor to the current state-of-the-art. The first EGR systems were used in some petrol-driven vehicles as early as the 70s. In the 90s, this technology also began to be used in diesel vehicles.